When we gaze up at the night sky, the moon's presence is a comforting constant. But did you know that this celestial companion is slowly drifting away from us? Join us as we uncover the fascinating science behind this phenomenon. Earth and the moon have been locked in a gravitational dance for billions of years. This dance is governed by the laws of physics and the forces of gravity. But the story isn't as static as it seems. One key player in this cosmic ballet is the tidal force. The moon's gravitational pull creates tides in Earth's oceans, causing water to bulge out both towards and away from the moon. As the tides move, they exert friction on Earth's rotation. This tidal friction slows down the rotation of our planet very gradually. It's a process that's been happening for millions of years.
This tidal friction creates a transfer of angular momentum from Earth to the moon. Essentially, Earth's spin is being gradually slowed, and this momentum is pushing the moon to a higher orbit.
The result? The moon is slowly moving away from Earth at an average rate of about 3.8 centimeters, or approximately 1.5 inches per year. While this might seem small, over millions of years, it adds up to significant changes. In fact, this process has been occurring for billions of years. Around 1.4 billion years ago, the moon was much closer to Earth, making the days shorter and the tides more extreme. To understand the impact of this gradual drift, let's look back in time. When the moon was closer, days on Earth were shorter, only about 18 hours long compared to the 24 hours we experience today.
These shorter days would have had a dramatic effect on the climate and life on Earth. The faster rotation meant more extreme tidal forces, which could have influenced the evolution of early marine life.
Today, the effects of tidal forces are still visible. Tides play a crucial role in coastal ecosystems, influencing everything from marine life to human activities. The moon's distance also affects other celestial events. For example, its current distance from Earth plays a role in the frequency and type of lunar eclipses. Looking far into the future, if this trend continues, what might happen? Scientists predict that in about 600 million years, a day on Earth could be around 25 hours long. Beyond that, the moon will be too far away to produce total solar eclipses as we know them today.
This gradual drift is just one part of the long-term dynamics of our planet-moon system. Understanding these changes helps us grasp the complex relationships that govern celestial mechanics.
So next time you look up at the moon, remember that it's not just a beautiful fixture in our night sky, but a dynamic part of an ever-changing cosmic system. Our planet and its moon are forever entwined in a delicate cosmic waltz. And as we continue to explore and learn, we'll gain a deeper understanding of the forces shaping our universe. Thank you for joining us on this journey. Stay curious and keep looking up. The universe is full of wonders waiting to be discovered.